Alright guys, this is trigonometry. We're going to be solving triangles using the sine rule. The sine rule is just any angle, taking the sine of any angle and dividing it by its opposite side. That creates a ratio, and you can set that equal to any of the other ratios in the triangle. So sine of A over A, sine of B over B, sine of C over C. Okay, if you want an explanation about why this is true, you can always go to the book on page 380, and it does a pretty good job of explaining why this works. Knowing when to use the sine rule is important because you have to have one angle and its opposite side. So for this first example, there is an angle, but we don't have its opposite side, so we can't use this for the sine rule. We have three sides on the second example, but we have no angle, so this doesn't work. Our last example, we have one angle and its opposite side, which means that we can find the other measures of the triangle. So let's do that. On this one, we don't have any labels, so in order to make sure we are consistent and organized, we make labels for it. So I'm going to call that A, B, and C. So our ratio is going to be sine of 67 over 14. And we're given the side for A, so we're going to figure out this angle first. So we have sine of A over 8. And then we're going to multiply by 8 on both sides. So we get sine of A equals 8 sine of 67 over 14. And then you want to get A by itself, so you're going to take the inverse sine of both sides. So you have A equals of 8 sine 67 over 14. And when you plug this into the calculator, you will get 32 after you round 31.7358. And so now that we have angle A is 32, we can find angle C by saying 180 minus 32 plus 67. And this gives us 81. And now we can use the angle 81 in order to find side C. So I'm just going to erase this work. And you always go back to the one known proportion, which was sine 67 over 14, and we're going to use sine of 81 to find C. Because our unknown is on the denominator, we're going to cross multiply, so we have C times sine of 67 equals 14 sine of 81, and you divide both sides by sine of 67, and so you get C equals 15.021, and you can just round that to 15. Or I guess it makes you do two significant figures, but that's just 15.0. Anyway, so C would be 15.0, and now you've solved the triangle by finding these three measures. Okay, let's do a word problem. So a ship is sailing due north. The captain sees a lighthouse 10 kilometers away on a bearing of 32 degrees. Later, the captain observes that the bearing of the lighthouse is 132 degrees. Now, how far did the ship travel between the two observations? So let's draw the ship's path first. So it's going north. and we have the first siding, so first siding, and then we have the last siding, right? The first siding, it's at 100 or 32 degrees, and it's 10 kilometers away. Let's make that a little bit smaller. So 10, and then at the last siding, it was at 132. Let's go down a little. There we go. And we want to know how far he had gotten between the first and the last siding, so we're going to put X there. The first thing that we need to do is label all of the parts that we can figure out, right? So we can find theta, and we can find, let's call this alpha. Okay, so theta is just 180 minus 132, and that gives us 48. And then alpha is going to be 180 minus 48 plus 32. And that gives us 100. So now that I've found those angles, I just need to determine which proportion I need to set up. So I have this and its opposite side. So I know that that's going to be the first proportion. So sine of 48 divided by 10. Now, I'm trying to find x, and I know that the opposite angle is 100, so I can use that proportion as well. So sine of 100 over x. And now I just cross multiply. X sine of 48 equals 10 sine of 100. And then I divide both sides. And so you get x equals, if you put that into your calculator, you'll get 13.3 kilometers. We're going to do one more word problem, and then we're going to go on to ambiguous cases. So there are two fire towers located at the base of a mountain 50 kilometers apart. Tower A sees a fire at 64 degrees angle of elevation. Tower B sees the same fire at 42 degrees angle of elevation. What is the elevation of the fire? So basically you have two towers at the bottom of a mountain. They see the same fire. You want to see the elevation of the fire. So basically you want to see the height, or you want to find the height. So let's draw the two towers, Tower A and Tower B. And they're 50 kilometers apart. Tower A sees it at 64 degrees, and then Tower B sees it at 42 degrees. And we want to find X, because this is the fire. Fire. Okay, so we want to find X. I know that if I take, let's call this B and let's call this A. I know that if I take sine of 64, I'm going to get out the opposite over the hypotenuse, which in this case for this triangle is going to be B, right? Or I could do the same thing with sine with 42, and it would be the opposite, which is x over the hypotenuse, which is A, right? Because the height meets the ground at a 90-degree angle. But I need to find A and B, or A or B. Either one is fine. Let's go ahead and do B. And before we can do that, we need to find the angle of F. So we're going to do F equals 180 minus 42 plus 64. And that's going to give us 74. Okay, so now we have our first proportion, right? Because we have this angle and the opposite side 50. So sine of 74 over 50 equals, and let's do, I don't remember if I said which one we would do, but let's do B, 42. So sine of 42 over B. So because the denominator is the unknown, we're going to cross multiply. B sine of 74 equals 50 sine of 42. Divide. We get out B equals 34.8. Remember that the whole point of finding B is that way we can put it into this equation here, so that we can find the height, right? So all we're going to do now is do exactly that. And this is getting kind of messy, so I'm going to erase this sine of 42 equals x over a. So now I'm just going to input B, sine of 64 equals x divided by, we said B was 34.8. And then I multiply both sides by 34.8. And so we get x equals, if you put that in your calculator and round, you should get 31.3 kilometers. That is the height of the fire. Okay, so let's go on to ambiguous cases. Okay, so remember that in our last video we said that sine of theta equals sine is the same thing as saying sine of the obtuse angle of theta, which is 180 minus theta. The ambiguous case is only applicable when you have two sides and an angle that is not in between the two sides, which is for most of the triangles that we use the sine rule for. There could be two triangles, but there is a possibility that there could not be. So we have to do a check. And I'll show you what I mean on the next example. But, yeah. Okay, so solve the triangle ABC if angle C equals 33, B equals 10, and C equals 6. So we're just going to make a triangle. I don't care what it looks like, as long as you have three lines that meet at vertices. Okay, so now we're going to label the sides, or the angles in the sides. Let's say that this is A, B, and C. C is 33 degrees. B is 10, and C is 6. So the first thing we're going to do is treat it just like anything else. We're going to find angle B. And this is really big. Let me make this smaller. Okay. So our proportion is the known angle and known side. So that gives us sine of 33 divided by 6. And we're going to go find B first. So we have sine of B divided by 10. Multiply both sides by 10. And so you get sine of B equals 10 sine of 33 over 6. And then take the arc sine of B, or the inverse sine of B, at both sides, and you get 10 inverse sine of 10 sine of 33 over 6. And what you get out is B is 65. Okay, now the thing is that this 6, this side, could actually come down this way. And you would have one angle A1, angle A2, right? So those could be different angles. You would have this one and then this one, which gives you two different sides. So you have this small A1 and then the overall A2, which is the whole side. Okay, so you have two options, and this is why it's ambiguous. So we have to look at it from two different cases. And so because we took the sine and we know that you get the same evaluation if you do it for the acute angle or the obtuse angle, that means that this could be two different B's as well. So B1 and B2. Okay, so in order to figure out, you have to do a check. Okay, so we go back to the known angle. In this case, it's going to be C, which is 33. If the known angle and the ambiguous angle together are less than 180 degrees, then it works, because you can only have 180 degrees, right? So it has to be less than, because you still have another angle that you have to look for, right? So in this case, the known angle, which was given to us, was 33, and the obtuse angle that we find, right? So you subtract 65 from 180, and you get 115, right? So this is the obtuse angle, the ambiguous angle. So we take that, combine them, and if it's less than 180 degrees, which it is, it's 148, then in this case there are two triangles that are possible with the given information. If ever you add the known angle and the ambiguous angle and you get greater or equal to 180 degrees, that means that that triangle is not possible. Okay, so we know that we do have two possibilities. One is with the angle B being 65 and angle B being 115. Okay, so now we have to do two separate, we have to do two more equations in order to find A1, A2, both the angle and the sides that are opposite of those angles. Okay, so I'm going to erase the work that we've done. And we're going to find A1 and A2. So A1 is going to be 180 minus 33 plus B1, which is 65. And A2 is going to be 180 minus 33 plus 115. So you get A1 is 82 and A2 is 32. And you just put that down here so that way you're keeping track of your triangles. Oh, and I should be putting the angle, sorry. Okay, so angle 1 is 82, and angle 2, or angle A2 is going to be 32 degrees. Okay, and now all we have to do is find the sides A1 and A2. So we're going to take the original proportion, which is sine of 33 divided by 6, and you're going to do one for A1, which is 82, so sine 82 over A1, and let's just go ahead and solve that one first. So you cross multiply and divide by sine of 33, you're going to get A1 equals 6 sine of 82 over sine of 33. and this gives us, after you round, 10.9. Do the same thing for A2. So sine of 33 over 6 equals sine of 32 over A2. Cross multiply and divide by sine of 33. We'll get A2 equals 6 sine of 32 over sine of 33. This equals 5.8. So A1 side is going to be 10.9. A2 side is going to be 5.8. Okay, so that was a lot of work for one problem, but you need to know how to check and then move on. I'm going to be doing another problem that shows a case that it's not possible to have the ambiguous case, so if you want to keep watching, keep watch. So, this triangle, do the same thing, draw your triangle. Oh, let me make it a little bit nicer, sorry. And we're going to label it A, B, and C. C is 64 degrees. The side C is 10, and A side is 8. So in this case, 10 is the one that could go on the inside. So it could be like this. So you should have, you could have two cases for A1 and A2, which would give you then two cases the two possibilities are B1 and B2, which gives you two possibilities for the A1, A2. Yep. Sorry, that's not making sense, is it? Yep, that should be, the 10 should move down from this way. Yeah, sorry. Okay, so this one could be like this. That makes better sense. Okay, so B1 is the one that you're going to be finding in B2. Is the other possibility. And then A1 and A2. We'll just go through it, okay? So, so sine of 64 over 10, and that could be for sine of A over 8. And so we're going to cross multiply. So we get sine of 64 times, or not cross multiply, I'm just going to multiply 8 on both sides, sorry. 10 equals sine of A. And then you take the inverse sine of 8 sine of 64 divided by 10. And that's going to give us what A equals. And so angle A is going to equal 46. So it should give us two options, right? So if A1 is 46, then A2 is 180 minus 46. And that possibility would be 134. 134 plus the original angle, which is 64, is greater than or equal to 180. So there is no ambiguous case. So you don't have to do two triangles. And so then you would just finish this out like you would a regular problem with the sine rule. Okay? I just wanted to show you where the case wouldn't be true. So So yeah,